Hi everyone, welcome back to our lecture on phonological variation. Now that we've introduced the distinction between token variation and type variation, we can now add some further complications, some further difficulties even, to rules themselves, namely seeing rules that show variable rates of application based on their outcomes or their environments. So it may not be immediately clear what I mean here, so we'll talk through and try to clarify this. Thus far, whenever we have written a phonological rule, whenever we've created a phonological rule, our rule has always predicted just a single outcome, usually in a single context. But sometimes the environment for a rule cannot be expressed in terms of a single natural class. So for instance, let's translate the following statement into a rule. A voiceless stop becomes a fricative when it is preceded by a fricative or the left edge of a word. So the issue here is that a fricative or the left edge of a word can't constitute a natural class. Fricatives, of course, make a natural class, but a word boundary and a fricative together cannot make a natural class. If we try to write this as two separate rules, then so the undergoers of the process are voiceless stops. So these are sounds which are minus voice and minus delayed release. And these become fricatives. So they become plus delayed release and plus continuant in these two different contexts. So either when they are preceded by the left edge of a word, that's option A, or option B is that they are preceded by a fricative. So they're preceded by a sound that is plus delayed release, plus continuant, and plus continuant. So those would be two separate rules that can express this. And variable rules become a bit more complicated. So if we come back to the example that we used at the outset, this invented word for apricot, Kathy, there you could find multiple possible outcomes perhaps in different contexts. And since rules, as we defined them, for instance, here with English coronal stop deletion, since rules might have different rates of application, then their rates of application could potentially differ between contexts. Now, if we collapse these two, if we want to put these two rules together, we can use the so-called curly bracket notation. So these two rules share the left side of the rule, the structural change. So that part would be the same if we collapse the rules. And to express that the rule has two environments in which it can apply, we can write that between the curly brackets. And the two options here are either the left edge of a word, or when there's a fricative, and that must be preceding the sound. And we can also use this same notation, the curly bracket notation, to put together rules with respect to where variation is happening. And there we only need to specify the rate of the different possible outcomes or outcome, which depend upon different contexts. So let's see an example now. So let's imagine that we're working with the English process of coronal stop deletion, which I introduced above. And let's assume that this process, in specifically the dialect of Trinidadian English, so spoken on the island of Trinidad, that it has the following rates of application. So when a word ends in the sequence consonant plus consonant coronal stop, and the following word begins with a consonant, then deletion applies 81% of the time. When the following word begins with a vowel, coronal deletion only applies 21% of the time. And at the end of an utterance, the process applies 31% of the time. So we could write 3 separate rules here. So again, let's take our process, which would have, it would look the same, essentially, but in slightly different contexts, there would be slightly different rates of application. So a coronal stop is subject to deletion. Let's copy this symbol here. Is subject to deletion following a consonant at the right edge of a word. And when the following word begins with a consonant, so after the word boundary, then we saw an 81% rate of application. If the following word begins with a vowel, only a 21% rate of application. But if we were at the end of the utterance, then there's a 31% rate of application. So these rules these 3 rules have the same targets with the same outcome. So in all cases, the target is a coronal stop, which becomes nothing, that is deleted. And part of the environment of application remains the same. It's always when there's a preceding consonant and before a word boundary, but depending upon a further condition in the environment, then we have different rates of application. So how can we make these 3 rules into a single rule using curly brackets? What we can do, we can take this single rule, and the part that varies, that is whether there's a consonant, a vowel, or an utterance boundary, that part we can place in curly brackets. And with each of those different options, we provide the probabilities of the application of the rule. So 81%, 21%, and 31% likelihood of application, depending on the precise environment. And that stands between curly brackets. So the curly brackets represent a variable part of the rule, of the environment for the rule, and each variable option there in curly brackets has different possible rates of application. And you'll of course notice here that these rates don't need to add up to 100%, and that's because each different environment expresses a likelihood of change or no change depending upon the context. So here I've illustrated this with branching derivations. So in each of the different contexts, in the case of where the following word begins with a consonant, the likelihood that the underlying coronal stop, ta or da, is maintained is only 19%. But when the following word begins with a vowel, the likelihood that the underlying coronal stop at the end of a word here is maintained is instead 79%. And this can become another possibility in which another dimension in which we can see variation are instances in which you see multiple possible outcomes for a rule in the same context. So here the variation would be at this part of the rule. So on the right side of the arrow preceding the environment. So for instance, my dialect of English has the following allophones of the voiceless coronal stop ta at the end of an utterance. It can be a regular stop, an unreleased stop. So you can have a word that is the closure of the ta is not released. It could be pre-glottalized. It could become a complete glottal stop, or it could become deleted altogether. So in utterance final position, there are then these 5 different allophones for that phoneme ta. So here we're making a sort of phonemicization diagram for a specific phonological context. So these are the 5 allophones. I'm just going to copy them here. So the unreleased T, the regular T, the pre-glottalized voiceless coronal stop, a glottal stop, or simply nothing. All 5 of those options could be said to constitute possible allophones, possible realizations of ta in this specific phonological context. And let's assume that these processes have the following rates of each allophone in utterance final position. So the most likely outcome is a glottal stop. The least likely outcome is the normal ta. And for writing a rule for each different possible outcome, our rule, the input to the rule will be a regular ta. And each of these different possible outcomes is an output from that sound. So each of those possible outcomes we would place between curly brackets now. And furthermore, between curly brackets, we would want to provide the likelihoods. We should provide the likelihoods of each of those outcomes since we are looking at the same environment in all cases, namely at the end of an utterance. So to complete writing our rule, our variable rule, we merely want to give the rates of finding, the likelihood of finding each one of these different possible sounds in each one of the different possible contexts. And finally, 10%. And thus we have a variable rule where the variation is in terms of what the outcome is. So we can contrast these two different rules that we've just written in terms of where the variation is located. In the coronal deletion process, the variation was located in the environment. Depending upon different environments, there were different likelihoods that the same change could apply. In the case with these different allophones of the voiceless coronal stop here at the end of an utterance, the variation was in terms of exactly what sound would be produced in that same environment. So to wrap up, we'll close with a small bit of mathematics, which I won't expect for you to be learning exactly, but just to illustrate how multiple probabilistic rules, multiple rules that have different likelihoods, can interact with one another and create different likelihoods for finding different pronunciations of the same word or sequence of words. So we have a situation where more than one variable rule is being used. And in that case, the outcome for a particular utterance can be calculated as the combined probability, the joint probability of two independent events. That is, we're assuming that the likelihood of the application of one process doesn't affect the likelihood of application of another process, unless there's a feeding relationship, let's say. So let's imagine a dialect of English having the two following processes that can generate token variation. So one is the coronal stop deletion process, which we've already seen. And let's imagine that in this dialect of English, it has a likelihood of application of 62%. And then we'll add to it a process of a diphthongization, through which the vowel a becomes a diphthong a when preceding a coronal nasal. And that occurs slightly more than 62% of the time. Now, let's create a phrase, banned books. So orthographically, that would be written as banned books. And there are 4 different possible outcomes here, logically speaking. Since these two words, since these two rules won't affect one another, there's no feeding or bleeding relationship between them, the likelihood of each different possible outcome is independent, and there are 4 possible outcomes. So we have a case in which neither rule applies, and we find the realization banned books with the vowel a and the coronal stop pronounced as such, and we would calculate that as simply, we arrived to something like 14% by simply multiplying 38 by 30.3765. That gives us this likelihood. So that was the likelihood that we multiplied the likelihood that a diphthongization did not apply and the likelihood that coronal stop deletion did not apply. Similarly, the likelihoods of each of the other outcomes are simply the likelihood that one rule applies and the other does not. So the outcomes are ban books, where a diphthongization has not applied, but coronal deletion has, or banned books, where a diphthongization has applied, but coronal stop deletion has not. And finally, given these rates of application, the most likely outcome is when both processes have applied. So we have ban books, and that would be calculated as 62% times 62.35%, which gives that likelihood. And these probabilities, these 4 joint probabilities, will sum up to 100%. So those represent the full range of possibilities. So as we've seen in each case, the joint probability shown in the last line of the derivation derives from the multiplication of these 2 independent probabilities. So here, this table below shows how the probabilities were calculated. If both processes apply, the instance where neither process applies, and the 2 instances where one process applies and the other one does not. So here, I don't want for you to worry at all about calculating joint probabilities. Just wanted to introduce this theoretical possibility that a variable rule can interact to determine the likelihood of specific utterances. I think our most important conclusion, or the most important message to take from this discussion of phonological variation, is simply that processes may have variable rates of application, and that lexical items themselves may prefer or prefer not to undergo a process. And as we'll see in the lectures on phonological change next week, thinking about variable processes gives us a way to move from a synchronic grammar where everything is stable and categorical to a different synchronic grammar. The variation provides a way of moving from one grammar to a different grammar by way of a grammar in which the situation is variable, where the situation is in flux or changing, so to say. Okay, so thanks for your attention today, and see you the following week when we come to talk about phonological change. Bye.